Hey folks, Dr. Emily here, and today we're talking about how great developers always build twice. Now, this insight is brought to you with over 50 years of software development experience. In fact, I suspect it's even longer, probably on the order of 60 to 75 years. And this lesson hasn't changed. That's the crazy thing, right? Software and technology changes all the time, super fast. But what you can rely on is principles that stand the test of time. These are principles that you can learn and master and take to the bank for your entire career, for your lifetime. And so that's one of those lessons that I'm going to be sharing with you today that is so important that every professional developer I have ever worked with or had the pleasure to meet, they all apply this principle. It is absolutely a best practice. So let's dive into it. All right, let's dive into it a little bit. Okay, so great developers build twice and they throw the first one away. This is from Fred Brooks' The Mythical Man Month. This is chapter 11. So I'll throw it up here. Fred Brooks, Mythical Man Month, chapter 11, Plan to Throw One Away. All right, it's an incredible book as a whole, but there's a couple chapters we've been highlighting that are really, really important, and they stand the test of time. They're still relevant today, even though this was originally published in 1975 based on work that was done in the 60s for our very, very first software systems. And so the past few, YouTube videos, if you want to get some replays, you can see more about just how these principles of software development don't change. They stand the test of time. And yes, even in the age of AI. So great developers, they build twice and they throw the first one away. What does this look like? This looks like you followed the tutorial. You applied the logic. You did everything right. But still, your project was brittle or buggy or just flat out broken. This isn't because you're not good enough. It's because great systems aren't born, they're rebuilt, right? They're rebuilt. So what I'm going to teach you today is how to apply this idea in your software development right now to become a better coder, all right? This isn't a new idea, right? So has anyone ever seen this version of Facebook? Pretty old, right? It's pretty old. At the end of the day, this idea isn't new. It's been used since the dawn of time. We build prototypes. For another example, how do we get to the moon, right? Did the astronauts just build a moon lander and, shoot themselves into the sky and land on the moon? No, they built prototypes. They did years of testing, and software is no different. And the best developers, these are the professionals that always have a job lined up. They do this daily, like every single time they code. Right? So this whole idea of planning to throw one away, yes, we use it in real life to build massive projects, but you can actually use this on the micro level in your day-to-day coding. And this is what separates the professional from someone who's just, doing coding tutorials on the weekend. This is what's going to enable you to up level to that six-figure level, to have a career where you're always in demand. Because at the end of the day, technologists that get the job done, they're the ones that get hired, that keep their jobs, that avoid layoffs because they know how to get things working. And so when you plan to throw one away on a daily basis, you are embodying that ability to get anything working. You have that discipline, that drive to see it through. And so planning to throw one away is how you do that. So let's dive into this. And again, if you guys are here live with me or watching the replay, drop a note in the chat. I'd love to see that you're here. All right? Super awesome. So have you ever built something that should have worked, but didn't? Have you ever built something that should have worked, but didn't, right? Where you followed that tutorial, you applied the logic, you did everything right, but still your project was brittle, buggy, or just flat out broken, right? This isn't because you're not good enough. It's because great systems aren't born, they're rebuilt. Okay, they're rebuilt over and over and over again. So this idea of throwing one away, it's not failure, right? It's part of the process, right? So Fred Brooks said it best. He said, plan to throw one away because you're going to anyways. Why? Because the first version teaches you what the real problem actually is, right? So when you're building software, especially, software is something that is so abstract. It's in your head. Like whoever the creator and the original idea for this product comes from, it's a thought in your mind. You have a vision, right? It's kind of like how an artist envisions a piece of work and they create it, right? Or a composer thinks of a piece of music and then composes it. With software, it's no different. It's an act of creation. You're creating something that never existed in the world before. And in the beginning, it exists in one person's mind. I want to do this thing, right? I want to do this thing. Well, you don't know all the rules yet. You don't know what it needs to be. And sometimes until it's out into the world, engaging with people, doing what it was designed and built to do, right? So in software that's really well established, compilers, word processing, Google Docs anyone, Microsoft Word anyone, PowerPoint, right? Like presentation software that's been done. Yeah, you can just sit down and do it, right? You might not even have to throw one away because you're building off of the example of dozens of software projects that have already implemented these ideas. But most new projects, like SaaS projects, or if you're building something new for your company, whether it's an internal piece of software serving the employees or an external piece of software, right, that's out there for the world, you're going to have to throw one away, right? Like Uber, Facebook, Airbnb, did they just come live on the scene fully formed? No, they had prototypes, right? The best builders create prototypes. So this idea of a throwaway first build, it's not failure. It's really just phase one, the phase one that we're supposed to have. And that's where the 4 pillars of problem solving come in. And I'm going to tell you more about that in a second. But I just want to let you know that there is a solution to this so you can do it smartly and intelligently and keep iterating and evolving. So I do want to hint at one thing here. Because this idea of prototypes is absolutely not new. The difference is that in software, we are always creating something new. If we weren't creating something new, the software wouldn't be required, right? Because with software, you have infinite scalability in essence, once it's created. So, for instance, like QuickBooks, a lot of people use it for bookkeeping. Do I need another software? No, only if QuickBooks doesn't get it done for some reason. Maybe it's faster, better, cheaper, better delivers a user experience, whatever it is. But once you have a dominant software, you don't need another. So for instance, in any area, there's like 3 main players, right? If there's more than 3 players, somebody's going to go. So like to give you an example of a really well-established piece of software, operating systems. The operating systems that you use every single day. We've got Windows, we've got Mac, and we've got Linux. Top 3. That's it. There's some other little flavors, but those are the ones that dominate the market. With the mobile form factor, we have different ones, right? We might have Android as well as iOS. But in every major, market, every major discipline and area, you usually end up with no more than 3 dominant players. And so once you have that critical mass, everybody knows what an operating system is supposed to do. Even if you've never heard of the word operating system before, you should be able to open files, save files, drag and drop them, move them around, right? Like there's well-established concepts that you need to be implementing. But when you're creating software for the first time, when you're building it from scratch, you don't know those things. There is no supposed to. There is no way it's supposed to be. It's whatever way works for your target users and for your business model. And so this idea of planning to throw one away, it's not a nice to have. It is absolutely essential. Let me dive into this. So what's the cost of not throwing one away, right? Like, okay, so let's say you're like, Dr. Emily, I don't feel like this, right? What if I just skip it today? I just don't feel like building this twice. Can I just build it once, right? Like, let's say we get kind of lazy. We feel like dialing it in, like, this is just a toy exercise. It's not real, right? In real life, the cost of not having a prototype can be literally disaster. It can be catastrophe, like a moonshot that blows up in the atmosphere. These things have happened. A bridge that gets destroyed once it's completed, right? These are all real events. Now, these are very visual, physical things that's like, oh my goodness. If you were the builder or creator of one of these things, how would you feel? Right? You would be like, oh my God, I'm never doing anything like this again. And if you were alive and watching as this happened and to see it like that, oh man, the rocket that blew up in the atmosphere because of Stack Overflow. Oh my gosh. Like the Java exception handling literally blew up the rocket. And so these things really do happen, right? These types of disasters and catastrophes. The challenge is that when we're developing software like on our phones, on our devices, I don't have this big catastrophe to point you to, right? Like, oh, my weight loss app had a glitch. Okay, I'll keep using it, maybe. So when you're building, software with lower stakes, but the potential for really big impact, there's not going to be like this like red flag, like, oh my God, I have to do it this way. What's going to happen, right? Because like software isn't real. So you're not going to have these big major catastrophic events to draw your attention to the fact that you must change how you develop. Except, do you want to become the go-to tech person in your organization? The one that everyone turns to, who always gets it done? The one who doesn't worry about layoffs because their new job is always around the corner. If you want to be great at your craft, you learn from the disasters, you learn from experience, and you learn how to prevent them. Because at the end of the day, smart professional coders, they're not just winging it. They're not winging it at all. They're rebuilding. So they're failing, but intentionally, rapidly to get to the solution that works, right? To get to the solution that works. So what I'm trying to communicate is that in software, when you're learning how to build software, you may not have this catastrophic failure. But by not doing this, it is costing you. It's potentially costing you a job of earning 6 figures or more. It's potentially costing you time because it's taking you longer to learn because you're not following the best practice. It takes discipline to do this, right? It takes discipline to plan to throw one away, to plan to do it twice. I have to tell you, I've done it more than twice on more than one occasion because this is what it actually takes to fully understand the problem. Building great software is a lot similar to like a research project where no one's ever done it before and you're a trailblazer, you're an innovator, like going into the wild trying to figure out how to get this thing working. That's what it takes to build amazing software. You don't have the luxury of knowing before you set out what it's going to be. And AI doesn't know either, right? ChatGPT isn't going to know this either because it's never been done before. ChatGPT is brilliant at, hashing, doing mashups of things that humans have already created, but creating something new, it's incremental. It's not going to be an order of magnitude. It's not going to be a leap. It's not going to be the next Uber, right? Humans are going to have to drive where technology goes. And so you're always going to have this situation, right? If you're creating innovative software that has the power to impact and change the world, you're going to be doing this. You need to plan to throw one away. And so what does this look like? What does this look like? Okay. So let me get, what does throwing one away look like? So I have a couple comments I just want to bring up. So Eric is mentioning it's a good idea to expect version 2.0 of the code to shine and just get version 1.0 out ASAP, proving viability. Absolutely. And this is the idea of, planning to throw one away, agile software development, rapid prototyping, getting things out the door as quickly as possible, because you're going to learn so much once this software is in the hands of actual real life users. It's incredible. Great observation, Eric. We also have listening attentively for those of us who are currently rebuilding a better task manager, which is one of our tasks inside the TechJoy Career Academy, where we train students how to become these amazing 6-figure software developers. And it's true. So what can a student take away from this, right? Because really this is applicable to software that's going to go into the world. So when you're a student and you're not yet at the level where you're working on a real project, in the academy, this would be students who are interns, who are working on our real client projects. getting that hands-on experience deploying live into production. So let's say you're not there yet and you're still working on the toy examples that are going to get you there, that are going to be the doorway, the gateway into those amazing experiences. So what does this look like? Okay, what does this look like? So one of the things you can consider is that anytime you're building a big project from scratch is allow time to have to build it twice. Trust me, the second time goes way faster. And it may not be a complete throwaway. Like you can reuse lots of it. So for instance, here's an example of a throw one away. So one of our very, very first client software projects that we ever did in the Academy, we made some choices. We were still learning and we made some choices that were not optimal. They were not best practice. And as soon as we realized that, we went back and we rewrote it at our own expense. But we didn't have to rewrite the whole thing from scratch. We were able to reuse most of it. All we had to rewrite was how the data model was interacting. And in fact, we were able to cut down the size of the software considerably because we were using a better library, a better architecture or design of the software, where things were going, where they were living. And so it set the project up for success long term. So planning to throw one away doesn't mean you actually literally have to completely scrap it. You want to plan to do that. And then once you've done it once, you've gotten it out into the world, it's in the hands of beta users. Now you do, a recap, right? A postmortem. And you're like, okay, what could be different? What could be better now that we know what we know? And you go back and you revise, right? So that's what I would also recommend as a student is thinking about planning to rewrite it and breaking that up in your time. So if you're like, okay, I've got 2 weeks for this project, I'm going to take the first week banging out the ugliest version of this thing that I can create. And in the second week, I'm going to polish it. And yes, in that second week, it could look like completely abandoning it and rewriting it, but you'll probably copy and paste from your old version, right? That's the thing, is that when you plan to throw one away, you're at a point where your knowledge is greater and you've already got this working version that you can go to. So if things don't work, you've got a reference point. So it's really, really helpful, really, really impactful. What does this look like for a software developer trying to build the next Uber, right? So we want to make sure that when we're, the two main ways that we can use this is greenfield projects and agile spikes. What the heck is that? All right. So a greenfield project is where maybe you have an established project. So maybe you're an employee, you're a developer, you're on a team, and there's an established piece of software that's been around for 5, 10, maybe even 20 years. What if you rethought it? What if you started from scratch and you rebuilt it? And in fact, that is actually how we identified that rewrite that I talked about our earlier software project. We did greenfield projects where everybody just tried to build it from scratch. We chose different technologies and we just tried it out. This is really, really common with professional developers. Like, should I use Next.js or React? Well, it's really hard to guess until you've experienced it. So just go build something using both and see what you like better, right? Another example, that might be more real world is like, okay, I'm a mom with 5 kids. So I need a minivan. That is the only vehicle that is going to accommodate us. Which minivan on the market should I do? Should I do a Chrysler? Should I do a Honda? Well, the only way to truly know is to try them. And I tried Chrysler for a while. And I really liked it, actually. But all of my neighbors rave about Honda. So I'm trying Honda. And it's literally a block from our house, the dealer. So we're trying that. I'm going back. I think I'm going to go back to my first one. But the idea is that I couldn't know that on the outside. I had to go try it. I had to test drive it. I had to see for myself how it felt, what I like about it, what I don't like about it, right? And so this same thing is true for these frameworks. So one of the things I see holding new coders back is when they don't take the right language for the job and they put too much emphasis on their learning. What do I mean by that? When you're a software developer, you use the right tool for the job. You use the tool that makes it easy. The amount of time it takes you to learn something new is so small compared to how fast it's going to be to get something up and running. And so software developers will invest in their learning so they can use the right tool. So picking the wrong tool could cost you weeks, months, or even years, right, of delay of getting something up and running. For instance, if you picked the language C to build a mobile app, it might never happen because you might not actually get that code to be able to run on a mobile device, right? Like that would be a deal breaker. You can't write mobile software using this, like you wouldn't start out using C. You'd start off using something else, right? And so you want to be able to be comfortable enough in your abilities to be able to pick up a new language or framework so you can use the right tool for the job. You don't want to overly attach yourself to your language of choice, because at the end of the day, that language isn't going to be here that long. I don't care what language it is. I mean, C is one of the longest, but it's not necessarily the most employable. I wouldn't necessarily recommend going into it unless you want to do operating systems, right? For like Mac, Linux, things like that. Then yes, maybe device drivers, that would be appropriate. But languages change and new ones come out all the time. And we don't know which ones are going to become the big players until they're really big. And then everyone has to learn them because that's where they are. Like if you're going to program for certain devices, there's only a couple languages that you can go learn. And you have to just learn to talk to it in that language. So for a software developer, we don't want to get overly tied or fixated on any one particular language. It's about how do I generally solve problems? And then I go learn the language that makes solving that problem easy, or I go learn the framework that makes solving that problem easy. Okay, so with a greenfield project, you can, and it's recommended that you do so, right? And we've done this for our projects too. Test a couple architectures, test a couple different tech stacks, frameworks, see which one you like better. Maybe like imagine taking a couple hours, let's say pick 3 front runners. You're like, I'm not sure if I want to do a MERN stack or maybe a LAMP stack. Maybe I want to do React, Next.js, or Vue. Pick 3. Pick your top 3, weigh them out, build something that takes you half a day in all 3. Because the potential time savings, it's like nobody's business because you can't really see it until you're in it. And so this is what professional developers do all the time. So that's a greenfield project. What's an agile spike, right? An agile spike is like a mini test project. And this is like super key when you're working on real world projects. If you're still in the land of developing small toy projects, like single file programs, this isn't going to make sense yet. But when you build actual like working webs and mobile systems with lots of moving parts and lots of technology, sometimes there's so much complexity, it's really hard to figure out what's going on when you see a bug. And so what professional developers do is they take the little snippet of code they're working on that's not working the way they expect, and they pull it out and they drop it into an agile spike or like a greenfield project where it's just a little itty bitty implementation, just enough to get that one buggy piece of code running. And then they work with it and they make sure that that code is working independent of the bigger project. Then once that's working, they integrate it. So now they know they've eliminated sources of uncertainty. That's really what a software developer's job is, eliminating uncertainty. Once they've tested it in this like sanitized, sandbox environment, it's like a clean room, right? They've analyzed their code here and it works the way they want it to. Okay, now they're going to put it in the live, or a version of the live deployed project that has all the moving parts. And now they'll know that when there's errors, because that software worked alone and the software you're putting into works without this, then the only source of bugs is how it connects and interfaces with the bigger project. I'm trying to think if I can see an example. It's like learning, let's say you're learning how to write letters, right? You're writing letters and you know how to write each letter individually, but you don't know if you know how to write it and put it into the bigger picture, right? I'm not sure that example was strong enough. I think another example could be like cutting hair. Like you might first you learn how to use scissors. You have to know how to use scissors to cut a piece of hair, right? And then you learn just how to cut a little bit of hair. And then gradually you learn how to cut and shape a whole thing. So you want to make sure that you know how to cut hair in isolation. Maybe you cut a Barbie's hair doll, right? Doll hair. And then you go to a live person because there's more happening when it's a live person. They're moving around, right? They're doing things. There's interactions that happen. And so that's the idea that we're isolating the source of uncertainty. Well, where is the bug? Is it my code? Is it the system I'm putting it into? How do I figure this out? Well, you literally take your code out. The change that you're making, you literally pull it out and run it somewhere else and make sure it works independently. That way the interaction is only with the differences of how that system is different from the original. Okay, excellent. So this is really about controlled learning, right? The discipline of breaking a problem down into its essence and only working on that and then adding in more of the real system until you feel confident that you can integrate into the project successfully. And even then, expect the unexpected, because that's likely to be what happens, right? So it's really about, managing uncertainty. That's really what a professional software developer's job is. So what can this look like? At TechJoy, we expect our students to rebuild, and we teach them how, right? Many of you are practicing this process right now with Dry, Don't Repeat Yourself, and it becomes even more so as you advance. Inside TechJoy, you learn how to think like a builder, not just a coder. You use early builds as a diagnostic tool, not a judgment, right? Not a judgment. And you get mentorship that celebrates iteration over perfection, right? It's about moving forward, getting it done, understanding, getting that clarity, and getting it actually working. And in fact, inside the 4 Pillars workshop that I'm hosting tomorrow night, you're going to learn how to deconstruct, rebuild, and deliver solutions like the best developers do. So if your first version of a program flopped, good. That means you're on the path to mastery. So if you've been stuck on that task manager, it's all good. Now it's time to learn how to build what actually works. Okay. So I'd love to invite you to join my upcoming workshop on the 4 pillars of problem solving. It's brand new. I've never done this before for the public. It's only been available to Academy members, where I'm going to teach you how to build anything with code, even if you felt stuck for absolutely years. It's going to be live tomorrow night. So if you're thinking about it, sign up now. There will be replays available. You can sign up here. I'll drop this link in the comments. Let me get that there for you. Here we go. If anyone wants to join, Academy students, you will obviously get access to this. So you don't need to sign up, but you're welcome to join us. Excellent. Getting that comment out there. So thank you so much for joining today. And I hope you learned something about how important it is to plan to throw one away in a professional software developer's toolkit. Every professional software developer I know does this, right? And if you'd like to learn how to do it for yourself, how to be one of those professional developers capable of earning 6 figures or more, join us for the 4 pillars of problem solving tomorrow night. Replays are available, and learn how to build anything with code, even if you felt stuck for years. All right. Have a good one, folks. Take care.